Welcome back to Getting Started with ArcMap. We will now cover our Block 3 of training, predicting the impact of the proposed road. So now that we've calculated the percentage of deforested area within 5,500 meters or 5.5 kilometers of roads, you'll use that percentage to estimate the area in square kilometers that would have been deforested if a proposed road was built. First, we'll digitize or draw the proposed road as a new feature class based on an image of the road. Then, we'll buffer the road and calculate the predicted deforestation area using its attribute table. So first, we're going to add an image of the proposed road to the map. The proposed road is in neither roads layer because those layers only show existing roads. So we'll add an image of the proposed road to the map, then create our own feature based on the image. This image came as a raster data set in the Brazil Geodatabase or the training Geodatabase. A raster data set is an image composed of a grid of pixels. The imagery base map in your map is also a raster image. Your other data is called vector data. Now, if necessary, open your Amazon deforestation map document. Then, in the Add Data button, add the Redonia proposed road layer. Click Add. Now, in the table of contents, we want to place it below our in the table of contents, we want to put it below our Redonia deforested area layer, which for mine it defaulted there. However, for some it may default higher up. So what we want to do is move it directly below our Redonia deforested area layer. Now, instead of a symbol, the proposed road comes with 3 color bands. These bands determine the color of each pixel in the image's raster grid. Now what we want to do is turn off all layers except the proposed layer, or except the proposed road and the Brazil colorized terrain base map. So we'll turn all layers off, then go back and select these 2. Now in the table of contents, we want to zoom into the image. So in the table of contents, we'll right click on the Redonia proposed road and left click on zoom to layer. Now this map zooms to the extent of the layer. And we see that the image shows a topographic view of the area with features such as national boundaries, some existing roads, mountainous terrain, and rivers. The proposed road is that thick black line in the middle of the image. Now, let's turn on the following layers. The cities layer, or the Brazil populated places, if you did not rename it, the official roads, and Redonia protected forests. Now the proposed road connects 2 official roads located here and here with cities near both endpoints of the road. Now we can use the identify tool to find out the names of each city, or we can temporarily turn on the labels, which we'll do now. Now, in the cities, we'll want to right click on the layer, then go down to label feature. Now we can see that the city's label is turned on here. We can also see that the city in the northeast has its city name turned on as well. Now the labels indicate that the cities the road will connect are Guajará-Mirim to the west and Campo Novo de Rodonia to the east. The proposed road also crosses 2 protected areas, a state park and an extractive reserve. The road was prohibited because it would have gone through these areas, which we can see is located in the tan color on our map. Now, since we've identified the cities, we can turn back off their labeling by essentially doing exactly what we just did to turn them on by right-clicking on the cities and turning off the label features. And then in the table of contents, let's move the Redonia roads above the Redonia proposed road layer and turn that on. Now, some portions of the proposed road, especially at the ends of the road, coincide with existing unofficial roads. Now, when we draw the proposed road feature, we'll trace these existing roads where appropriate. Now, on the ArcMap menu, we're going to create another bookmark. So let's go to the Bookmark tab, create bookmark, and then this bookmark we'll call Proposed Road. Then click OK. Next, we'll create a new feature class. So using the image as a guide, we'll digitize the proposed road as a feature. Now, we can digitize the proposed road as part of one of your road layers, but that would alter the reliable data with the feature representing a road that does not actually exist. So instead, we'll create a new feature class. So we'll open up the catalog menu in the standard toolbar by clicking this icon, and then we'll see in the right that the catalog menu opens back up. Now, also of note, you may have already had the catalog tab from earlier, making the default Geodatabase as the training set, and you could alternately go to the catalog by clicking that tab. Now what we want to do is navigate to our Brazil training database, brazil.gdb. And inside of that, we'll right-click on the Brazil Geodatabase or our training database, right-click, click New, and then go down to Feature Class. And then the Feature Class dialog box opens. So we'll see that we have two input fields, a name and an alias, and then what type of feature we're adding. So for name, let's type planned road. Now remember, for the name, you can't have spaces. However, for the alias, we'll call it planned road as well, but we'll put a space in there. Now for the type, since this is a road and a linear feature, we'll click line. But as you can see, we have multiple options under this dropdown. But again, for this feature class, we'll choose line. Now at the bottom of the feature class window, we'll leave the geometry properties blank or at their default setting, and then we'll go down to the bottom and click next. Now since I've already worked through this training, I already have this feature class named, and you can't have a duplicate feature class, or from this method you cannot save over it. So I'm going to go back and change mine to proposed road 1, but you'll keep yours as planned road. Now next, we'll choose the feature class's coordinate system. A coordinate system defines positions and measurement values of geographic features on a map. So we'll learn more about coordinate systems later in the project, but for now, we'll use the coordinate system used by the layers already on our map, which you can quickly choose from the list. So in the pop-up, in the feature class pop-up for the second page, under the coordinate systems, we'll expand the layers folder at the bottom. Now we'll want to click South America Albers equal area conic because this is already used, if you drop down, for our following layers. Once we've selected the South America Albers equal area conic, we'll select Next. Now, the XY tolerance on the third page, this part of the feature class dialog allows you to specify XY tolerance. XY tolerance defines how close two coordinates must be to be considered the same coordinate. Now, for our instances of drawing our planned road, the default value is fine. Then we'll click Next. Now on our next page, the next parameter is for database storage configuration. For our training in this introductory course, we'll just leave the defaults as fine. Now lastly, we'll add the attribute fields. The planned road feature class should have the attribute fields like the existing roads feature class, although we can manually create fields by entering names as well as data types. Now you can also import attributes from an existing feature class, which is what we'll do. So let's click the import button towards the bottom of our pop-up box. And then we'll navigate to our Redonia roads layer. Let's see. So once we have that highlighted, we'll click Add. And then as you can see, once we import that, it matches the Redonia roads layer fields exactly. So we have our object ID and shape as part of the default, but then from the import of the Redonia roads, we now have name and status. Once we have completed this, we'll click Finish. Now, the planned road feature class is created in the Brazil Geodatabase and added to the map as a layer. However, it's not displaying anything because it's an empty feature class at this point in time. However, we're about to change that. Now we're moving on to digitizing the proposed road. Now to add the feature of the proposed road, we'll use the image as a reference, then trace the unofficial roads that coincide with the road's location. Essentially, using existing roads to start on either end of the road. Now to start digitizing the feature, we'll begin an editing session. To do that, in the table of contents, let's click on the planned road, right-click, Again, mine's going to look different. Mine's planned road 1. Yours will be planned road. And we'll want to point to edit features, which is about midway down, then choose Start Editing. Now an editing session begins and the editor toolbar, I have a pop-up here. So we'll continue because these errors, essentially what it's doing is the projection is not the same as what we're editing in, but that's fine for this training session. So now that our editing session, and we've already dismissed the pop-up, begins, the editor toolbar is turned on. It's located in the upper left-hand corner of our map. And this shows several options for editing. The edit tool is active by default. The edit tool, located here, selects or moves features from any editable layer. This tool is useful for modifying existing features, but unfortunately for our uses, it does not create new features. Now, as a tip, any toolbar can be moved by dragging it around the map, as I'm doing now. If moved to the top window, though, it'll dock next to our standard toolbars. So, on the editor toolbar, we want to click the Create Features, which is the last icon on the toolbar. Then, as the Create Features window pops up to our right, we want to make sure that the planned road is highlighted. And then we'll click Line in our construction tools at the bottom. Now you'll notice as we move our cursor back to the map that the crosshair or the pointer changes to crosshairs. This allows you to draw features. But before we begin, let's explore some drawing behavior. So let's point to some features on the map, but not click anything yet. So as you can see, I'm hovering over different features in which their names are popping up. So here's one with the city's point. And then we're tracing the official roads. Oh, and now we're on the roads or unofficial roads of Redonia. And let's see if we can find anything else. Oh, and here's the edge of our protected forests. And I think that's looking at the looking at the table of contents. It looks like we've identified everything that's turned on and with vector data. So as you can see, the pointer is pulled towards features. Now, our ArcMap calls this feature snapping. Snapping makes it easy to connect new features to other features. However, it makes it very difficult to create features that are close to other features but do not touch exactly. Now, because the planned road connects to official roads, and city layers, snapping will be very useful. However, you'll turn off other feature layers so you don't accidentally snap to them while digitizing. Now, if snapping is not enabled by default, you can turn on the snapping toolbar by clicking Customize up in the main menu, pointing to Toolbars, and then turning on Snapping. On the Snapping toolbar or menu bar that's popped up here, click Snapping and choose Use Snapping. Ours is default that is on, as yours most likely will as well. However, if you weren't getting the pop-ups like I am now, you'll want to go through that option and turn them on. Next, we'll turn off the protected forests layer. Again, giving us one less thing that will snap to. So now, the only visible layers are the Brazil populated places, or our cities layer, the planned road, official roads, Redonia roads or roads, the Redonia proposed road, and Brazil colorized terrain 50-meter layers. Now on the editor toolbar, we want to start by clicking Trace, which is this polygon listed icon. And once you select it, we'll use the scroll wheel on our mouse to zoom in to a good start point, or essentially this intersection here. Once you get there, left click. And then as you can see, we don't have to keep clicking. What it does is you drag your cursor over the proposed lines, the unofficial roads in this case, and it'll trace those features. Now, as I just did, you may go off the path you want to, but to get back on it or to essentially erase that selected portion, just drag your cursor back to your last good point and continue onwards. So as we digitize this, we know that the Trace tool traces the existing feature, making it useful for portions of the proposed road that overlap sections of existing roads. Now we'll use the scroll wheel to zoom to the left endpoint of the proposed road. You can do this by holding down the center wheel mouse button and dragging over. Alternately, you can hold down you can hold down the C key to make the panning option active. So as you can see, I'm holding down C. Well, you can't see it, but I'm holding down the C key. And the hand option pops up, and you can left click and drag the map. Now, don't drag the map outside of your trace area because when I release the left click and release the C key, it picks back up where it was. But as you can see, I kind of over highlighted an area. So we're working our way back and then continuing on. Now, my favorite way to pan is definitely using that holding down the center mouse wheel, not scrolling, just pressing it inwards. But if you don't have that center mouse wheel, then the C key works just as well. So we've reached the end of the unofficial roads. So what we're going to do now is, well, essentially we've ran out of areas to trace. So what we'll do now is change to straight segment. This will allow us to continue digitizing. So you may have noticed that my highlight disappeared on me. That's because I made an error. And this is probably a critical error that you may have done as well. Once you get to the end of the traceable section, make sure you left click. And when you left click, it essentially puts all of the vertexes on that road we just traced as green boxes. And then once you left click on that traced feature, you go up to the editor toolbar and select the line segment or the straight segment feature and continue on the path. If you made the mistake like I did, pause the video now before continuing and retrace those features. So pause now. Now continuing on, so we have the end of our trace segment active. We also have straight segment pressed. So what we're going to do is just digitize based off of that underlying image on the Redonia proposed road. So what I'm doing is I'm going through and clicking the vertices in that road, which digitizes the area between as a straight segment. So as we go through this, as you should be doing now, we end up further east to where the unofficial road reappears. So what you want to do is get close to it, but not on it. Or you could just use the snapping feature, then left click. From there, we'll want to go back up and click on the trace feature, then continue on down that path. Now, if you're not getting the trace function, make sure you click on that last point, left click on that last point of your straight segment. Now, a good practice is sometimes when you're panning, you lose your position. So at some points, with snapping turned on, it's good when you're tracing to left click a point, then left click again to continue tracing down that feature. Now this snapping and tracing function really makes this job or this task a lot simpler by having to digitize this whole section with all of its breaks and non-straight segments using the straight segment feature. So as you can see, I've reached the end or that far eastern portion of the proposed road, and I've reached the official road endpoint. So let's click or snap to that official road endpoint. Then double click, and that completes the feature. So let's now zoom out to take a look at our digitized proposed road. So go to your bookmarks, click proposed road. So if you're satisfied with the entire length of that proposed road, then we'll go ahead and save our edits. Now, until you save, all of your edits can be undone by ending the editing session or exiting ArcMap. However, I'm satisfied with mine, so I'm going to go ahead and save. However, if you would like to go back and redo that section, pause the video now before we continue. So I'm satisfied with the digitized road, so we'll go up to the editor toolbar. Again, mine's right next to the standard toolbar, although yours may be on the map, but mine will go back, click the editor dropdown, save the edits. What this does is it saves that line to our planned road feature, and then we'll stop editing. Additionally, we'll close the Create Features pop-out on the right-hand side of the menu. Now, in the table of contents, since we just digitized the road, we can get rid of this imagery layer, Redonia Proposed Road, because it's no longer needed. So let's go ahead, right-click on that, and remove it. Now on the Tools toolbar, let's make sure that everything's cleared, which at this point nothing is selected. However, you may have this icon turned on because you have something selected. Just make sure you press that before moving on, because we're now going to be entering our next step of block 3, symbolizing and adding attribute data to our proposed road. So now that our proposed road has been digitized, as evident by this new magenta colored road on my map, may look a little different on yours, but it's thin and difficult to see on the map regardless. Also, when we added the attribute fields, when we created the feature class, these fields did not contain attribute data. So in the table of contents, we'll drag our planned road layer below the official roads layer. And then we'll double click the layer to open its layer properties. Once the properties are open, we'll click on the symbology tab. Now, we'll give the proposed road symbology similar to that of existing roads, but it should also be distinct and attention-grabbing. So we'll import the symbology from the official roads by doing this, and it defaults here, but you can select it through a drop-down. Now, in the drop-down, it's going to list all of our vector data that has essentially that is a linear feature. So right now we have 2 roads and official roads, but we want official roads, so select that and click OK. So what this does is it imports the symbology definition from our official roads, but again, we want it to stand out and be distinct. So to do that, we're going to change it from our current color of raw umber to one box next to it on our color spectrum, or cherry cola, a more reddish color. Then once you do this, we'll click OK and view our new road. So next, we'll add attribute data to our proposed road feature. So in the table of contents, we'll right-click our planned road and open the attribute table. Now, the digitized feature is the layer's only feature apart from object ID shape and shape length fields. The layer has attribute fields for name and status. Now, neither field contains attribute data and is null. Now, if you're in an editing session, you can directly edit the attribute tables. Now, we stopped the editing session moments ago, and we're going to restart it. To start editing specifically this table is to go to Edit Features and start editing. So we receive the same pop-up message, but again, we're going to go ahead and continue. So to edit the attribute table in the name column, what you do is you just double-click in the cell, very similar to how you would in Excel or other tabular type programs. So in the name, we're going to type BR421 and press enter. So this is the name of, or rather, this is going to be the extension of that official road's name that starts in the east and then merges into the proposed road or the planned road. Now, in the status field, we're going to change this to reflect its proposed status. So double-clicking, and then once you've typed in proposed in the status cell, click enter. Now, once again, we're going to stop our editing session. So going up to editor, we're going to save our edits, and then we're going to click on editor again and stop editing. Once we have stopped our editing session, we'll go ahead and close our attribute table. So next, we're going to find the potential deforestation of the road. So we'll estimate the deforestation the road would have caused. Now, in the previous lesson, we determined that the percentage of land that was deforested 5.5 kilometers from a selection of existing roads. Now, to find the total area, not just a percentage of potential deforestation around the proposed road, we'll build a buffer of the planned road to the same 5.5 kilometer distance, then multiply the buffer area by the percentage of deforestation observed around existing roads. Now, we'll also remove areas of existing deforestation so that they won't be included in our overall total. So once again, we're going to use our geoprocessing functions of ArcMap. So in the ArcMap menu, click Geoprocessing, then choose Buffer. And this brings up our buffer dialog window. So for input features, let's choose our planned road. Now again, mine's planned road 1. Yours will likely just be planned road. And then we'll change the name to planned road buffer. Now mine defaulted to this, yours likely as well, so that's fine. For linear unit, now it defaulted to meters on mine. You also have the option of kilometers, but let's stick with meters, and we'll type in 5,500 meters. Now if you're using kilometers, obviously that'd be 5.5 kilometers. Then we'll click OK. So the tool will run, and then the buffer is added to the map. Now the planned road buffer layer covers some of the same areas that already have roads and deforestation, but it's difficult to tell because of the layers order on the map. So what we'll do in the table of contents is move the planned road buffer below the deforested area buffer, or the deforested area layer, and then we'll turn it on. Now there are some areas where deforestation has already occurred. It may not be obvious given the default default symbology on your planned road buffer. So once again, let's change this for higher contrast. So by clicking on the symbol, what we'll do is we will change this again to gray, 70, 80, or black. It really doesn't matter, but I think I'm going to choose gray on this one. We don't really need a color for outline, and then clicking OK. Now you can really see those areas that have been deforested due to the unofficial roads already located. So we don't really want to include these already deforested areas in our analysis. So what we'll do is we'll remove the existing deforestation from the buffer with another geoprocessing tool called erase. The erase tool subtracts parts of one layer that overlap another layer. And the erase tool is not one of the tools that can be accessed from the geoprocessing menu, but instead we'll search for it. So I stand corrected, we'll search for it using the search function. Now on the ArcMap menu, go up to next to on the same standard toolbar where the add data is, continue right of catalog and click search. And then we see that the search tab opens up on the right hand side. Now also, because I've been using ArcMap extensively, I already have a tab located there. You may or may not, but that's an alternate method of finding the search function. So this search function allows us to search for different tools that aren't necessarily nested under a menu or have an icon button listed on what is our standard or already added toolbars. So in the search box at the top, we'll type erase and press enter. So what we're looking for is our erase analytical tool. So that's the top search result, at least on mine. But again, we're looking for the erase analysis parentheses tool, and then we'll click on the hyperlink, which brings us to the erase tool dialog box. Now, again, this is very similar to our other pop-up dialog boxes, that it has a series of fields, but most importantly is our show help button down in the corner. Again, this provides a description of each field, as well as what are acceptable inputs into those fields. Now, to continue on for our input features, we want to select our planned road buffer. For erase features, we want to choose our deforested area. So on mine, for input, it was planned _ road 1. Yours may be road _ buffer. For erase features, it's Rodonia _ deforested _ area. Now, this tool will take the input features and subtract them from areas that overlap with the erase features. In our case, it'll remove areas of deforestation from the buffer. Now, We want to confirm that the output feature class will be saved to the Brazil Geodatabase. In my case, it is. And we want the output name of our layer to be something that's more easily recognizable. So each time we conduct, or rather run a tool, it adds an underscore, then the name of the tool. So now we're at essentially 4 words deep. So let's delete this and change it following the / Brazil GDB / everything after that last / let's delete and replace with erased underscore buffer. And then we'll leave our XY tolerance as blank, then click OK. So the tool runs, and again, it may vary on time it takes based off your system's performance, but then it adds the layer to the map. Now, the erased buffer is a single multi-part feature. Now, to find out how much this area would have been deforested, we'll need to multiply the area by the percentage value that we obtained earlier. Remember, this value is stored in the attribute table of the roads buffer layer. So let's open that up to remember. So on mine, it's the second to last in the table of contents. But to open it, let's right click and open the attribute table. So we can see that mine under percent deforested is 36.56 or 36, a little over 36%. So what we'll do is we will copy this value to be used later. Next, and also a caveat of note, your percentage, again, because the selection area compounded by the difference in roads and buffer area, your percentage may be different. Well, it will be different, as much to 10% over or below. But continuing on, let's make sure that we have copied our percent deforested. And then we'll open our erased buffer attribute table. Again, so it opens it at a tab or on a tab in our already open attribute table. Now, once again, we're going to add a new field to estimate the deforestation of the buffer around the proposed road. We'll then multiply the total area by the percentage value we just copied. We'll also convert the area from square meters to square kilometers, so the value is relatively appropriate for what it measures. So on the tables toolbar, again, in the erased buffer tab, we'll go up and select add field. So under the field name, we'll type in potential deforestation. Remember, we can't have spaces when we're naming it. For type, we'll choose double. And then for our alias, we'll type in potential deforestation in square kilometers. I'm just copying and pasting it here from up top, but it should be potential deforestation. And then at the end, we're putting in parentheses our unit of measure or square kilometers. Once you have this, click OK. And we see that the field is added to the attribute table. So next we'll use our field calculator again to find the estimated deforested area in square kilometers. So let's right click on this column and click field calculator. So again, it gives us the warning that we're going to do this outside of an editing session. That is fine. So the field calculator opens. Now, the expression for this field is more complicated than the last equation because we also want to convert the square meters of the shape area field to square kilometers. So 1 kilometer equals 1,000 meters, which means that 1 square kilometer equals 1 million meters. So under the fields, let's double click the shape area. This adds it at the bottom expression area in the large white area at the bottom of the window. So let's also click the division button and divide it by 1 million. Again, we're converting, in this case, from square kilometers back to our unit of measure. Now we'll add parentheses around this equation. And then once we close our parentheses, we'll add the multiplication symbol and paste our percentage value. So I've already forgot what that percentage value is, so we'll go back to where we stored it in our, either if you've stored it in your notepad, but I do remember mine now. Of course, I've paused it and looked it up since, but it's 36.56%, and then since it's still represented as a percentage, we'll have to go back and divide that by 100 to get our ratio, and we'll also put a parentheses around that one as well. So by the time you're done, what you should have is the shape area divided by 1 million, times it by your percentage divided by 100. And then we will click OK. So once it runs this math, according to this analysis, approximately 494 square kilometers were saved by canceling of the proposed road. Now, your value may be slightly different. Once we do this, we can close the attribute table, return to the Redonia bookmark, and save our map. So, although your value may vary from the example, the overall story remains largely unchanged. If the proposed road had been constructed, several hundred square kilometers of land would have become deforested, much of that land in untouched rainforests. Now, in addition to the deforestation that would occur directly as a result of the road, even more natural forest may be lost due to unofficial roads branching from the official road, or the conversion of surrounding land to private